Okay. So now we want to work with some more set operations. Okay, so we have two other laws here that I want to show you called De Morgan's laws. I don't know that it really matters that you know these laws, but it says that A union B complement is the same as A complement intersection B complement, and we're going to try to figure that out with pictures in a minute if this is true. And then the second one is that A intersection B complement is the same as A complement union B complement. So let's see if we can figure out the first one here. So what would A union B complement be? Well, remember that union means A and B. So A union B is all of this. So A union B complement would be all this out here, right? So if everything that's not in A and B, A or B, union is or, intersection is and, sorry. So this would be A union B complement, right? So is that the same as A complement intersect B complement? So A complement would be, so I'm going to draw on this. Don't do this yet, okay? A complement would be everything but A. So I'm going to do this in different colors. So A complement would be all of this. Yes? B complement, I'm going to change colors here. B complement would be everything but B. So that would be oh, not that. Right? And so where would the intersection of that be? That would just be where there's both yellow and blue, right? So where's there both yellow and blue? Only on the outside. None of A, none of B, because that's just blue, that's just yellow. So that's the same. Does that make any sense at all, what I'm saying? So A complement intersect B complement is everything that's not in A intersected with everything that's not in B, which would be just the outside. So those are equivalent, right? That's not an official proof because we just did pictures here, but that is what that's saying. So those are equivalent. And then what about the other one? I'm going to write it over here. So the other one says A intersect B complement is equal to A complement union B complement. Is that what it says? Yeah. So let's think about what that one is. So what if we just did A union B complement? So remember, what would be A union B? Oh, I wrote that wrong, didn't I? Gosh, why do I keep saying union when it's intersect? I hope you caught that. It's intersect here, sorry. A intersect B complement. Well, A intersect B is where they share it. So this is A intersect B. So the complement of that is everything else but the overlap, right? So it's everything on the outside, everything but that little part there. And then what about A complement union B complement? So A complement would be everything but A. So again, I'll use my two colors, okay? Did I write that one right? All right. Everything but A is A complement. And then everything but B everything but B would be all of this, right? Oh, not B. So this would be B complement. And if I want the union of that, right, I want both of them. So I want everything that's shaded, either green or yellow or both green and yellow. And again, you can see that those are the same thing. So those are a law with sets. Not that you have to memorize it, but it's just something to think about. Okay? Okay, so now let's look at this example, and then maybe we'll save the last ones here for us to do. But it says cyber privacy. In a poll surveying 1,500 registered voters in California, the respondents were asked to rank the following companies on a scale of 0 to 10 in terms of how much they could trust these companies to keep their personal information secure, with 0 meaning that they don't trust them at all. And you can see that Apple, Google, LinkedIn, YouTube, Facebook, and Twitter were all given a rating between 0 and 10. So it says let A denote the set of companies that have a rating of 2 higher than 2.5, B have a rating between 2.5 and 4, and C denote the set of companies that have a rating lower than 3. And then we want to find each of these. And this is practicing the notation, okay? So find the following sets. First, what would set A be? Higher than 2.5. So higher than 2.5 would be all of them but Twitter, right? And so we could say that set A is Apple, Google, LinkedIn, YouTube, and Facebook. And if you want to shorten that up, shorten it up. What would B be? Set B are companies with a rating of 2.5 to 4. So this one's over 4. So it would just be these 4, right? So that would just be Google, LinkedIn, YouTube, and Facebook. Oh, I lost my chart up here. C are companies that have a rating lower than 3. So lower than 3 would now be these 3, right? YouTube, Facebook, and Twitter. YouTube, Facebook, and Twitter. And now that I have my sets, I don't really need the chart anymore to do these other problems. And if you want to make a Venn diagram to help you on these, you can. But mostly you need to start knowing the notation. So what does A union B mean? Remember, union means this or that. So everything in A, everything in B. So A union B is going to be Apple, Google, LinkedIn, YouTube, Facebook. Which is just A, right? We could say what? B is a proper subset of A. What would be B intersect C? Intersect means this or that. This and that, I mean. Gosh, I keep messing that up. What they have in common. So what does Google, LinkedIn, YouTube, Facebook? YouTube, Facebook, Twitter. What do they share? Looks to me like YouTube and Facebook. What about D? A complement is everything that's not in A. And there was only one thing not in A. That was Twitter, right? So A complement is Twitter. And we want to intersect that with B. And look at B. B doesn't have Twitter in it. So what does that mean? Where do they intersect? They don't intersect, right? So that means since they don't intersect, the answer is the empty set. They have nothing in common. And then E, what is A intersect B complement? Well, B is Google, LinkedIn, YouTube, Facebook. So that means B complement is going to be Apple and what was the other one? Twitter. So now where do they intersect? It looks to be like Apple is the answer, right? Just Apple. And so that's what it means when you're trying to use this notation, okay? Okay. This is another one using that. That's one of those theorems, De Morgan's laws. I want you to try this one. See if you can do this and see if you can do this and see if you get the same thing. And then we'll check that one in class. And the same thing with this one. It's another example where they're giving you a set in set notation. And I want you to think about if you can think about what these are going to look like. And then how could you write it? Maybe how would the Venn diagram look like? And then how would you write it using union and intersect? And we'll do this one in class as well. Okay?